Hello everyone, welcome to Roots of Unity. My name is Marzukh and I'm back with another video series. This video series will cover vectors. So what are vectors? These are some examples of vectors. Yup, they are all vectors. Okay, so why vectors? Why do we need them? Well, vectors are quite important as they represent both the direction and magnitude. So you'll see their implementation in mechanics and physics and other vital subjects as well. It's important in the field of engineering. Basically, vectors are quite useful. They can represent anything, but usually they represent positions of x, y, and even z coordinates. They may also show velocity or acceleration in the x, y, and z direction, but let's not be concerned with those right now. For now, we focus on the position of the x, y, and z coordinates represented by vectors. Okay, now let's see an example. Let's see vectors in the 2D plane. This is the normal x and y axis. We can see the following coordinates, a and b. Let's now take a short journey from the origin to these points. We'll first go to a and then to b. To reach a, we first wait, let me just show another color. This is the journey that needs to be taken. Okay, to reach A, we first go 2 units to the right and then 3 units vertically upwards. This actually can be represented in vector form. Wait. In the vector form, OA is equals to 2, 3. This 2 represents the number of units needed to go in the positive x direction, and this 3 shows in the lower row, shows basically how many units needed to go in the positive y direction. Note that the vector represents the direction as well as the distance. Note that the magnitude of the distance can be calculated from this vector, but I haven't taught you yet. I will do so in the upcoming videos. Anyways, we call this a position vector because this vector is specifically, it starts from the origin. That's why we call this a position vector. Okay. Now, for the remainder of the journey, we need to go to B from A. So from this is the vector. I'm just gonna erase these parts. Okay, yeah, looks pretty clean. All right. So yeah. So now basically we need to calculate the AB vector, right? Okay, so we can take an indirect way of calculating the AB vector. What we can do is go back to we go back to O from A, and then from O to B. So basically, this is the resulting, this is the OB vector, right? So first we need to go back from A to O, and then from O to B. The resulting vector is the AB vector. So why does this indirect route work? First thing first, vector represents both the direction and the distance, right? So this AB vector will give the distance in this direction only and not the sum of the distance OA and OB. This is very important. Okay, so here we go back from A to O. So since this is in the opposite direction, let's put a minus to this vector, right? Yeah, so we're adding this. We're adding this vector AO and OB. So why are we adding this though? Well, we basically said go here and then go here, right? So in vector form, we would have to add the vectors to represent this. Now you'll notice that this has actually formed a triangle, right? Wait, let me just show with another color. This is the vector triangle. Notice that we're calculating AB, right? So it's very simple. To calculate AB, we have to go from A to O and then O to B. Okay. Anyways, so we're adding this, right? So how do we get AO? Well, we know OA, right, from here. And AO is nothing but negative of OA because it's actually in the opposite direction, right? So negative of 2, 3 plus the position vector of OB, which is just the coordinates, 5 minus 1. We add this. When doing negative, the minus sign is actually multiplied to each of these elements. So it's minus 2 minus 3 plus 5 minus 1. And the resulting AB vector is 3 minus 4. Okay, so this AB vector is shown here. Okay, now because of what you know, you can now calculate more complex vector additions. Let's go for this one. So we have to find out the coordinate of the point T. Okay, well, basically we can do this by first finding out the position vector OD, right? To find out the position vector of OD, we have to use this vector triangle. So we can go OA and then from A to D. So this is the resulting vector, OD. Okay, so we have to find out OD, right? So from triangle AOD, this is the vector equation that we need. So we can find out OD if we know both of these. So we know OA, right? It's 2, 4. OA is equals to 2, 4. But we don't know AD yet. Well, we can find it out using this indirect method. AD is this, right? It can be found easily by taking this direction. Oops. Okay. All right. So it's actually AD is actually equals to AB plus BC plus CD. Well, notice that here, the arrows, right? Notice carefully, the arrows represent the direction. So this arrow is actually representing, is pointing away from D and towards C. So this is actually the DC vector. But we need the CD vector, right? But that's not a problem, right? Because we know that since it's in the opposite direction, the CD vector is actually just negative of DC. And that's exactly what's here. So continuing that, we just plug in the values. So these are all given. So we can all continue forward. This will get canceled out, and hence this is the only resulting vector. So AD is this vector. And then we can calculate the OD vector using this here. So we know OA, which is basically just the coordinates, since it's a position vector, right? And we know AD. So if we add them, we can get this. And we know that a position vector is just the coordinate in vector form. So D is actually minus 2, 1. Well, that's all for today. In the next video, we're going to learn more. So see you later.